In this video, I want to introduce the idea of static memory. So static memory, if you recall from the overview, is memory that's going to be around for the duration of your program. So it's not like something like the memory required for functions, because functions come and go, right? We run them, they do stuff, and then they complete and they exit out. Well, the variables we're talking about here, or the memory we're talking about here, are things that must be around or persist for the entire execution of your program. Now, the entire the amount of memory you need to allocate statically is going to be determined offline or statically. Meaning your compiler is going to be able to look at your program and basically figure out how many variables are there that must be around for all of time. So generally speaking, there are two categories of variables that have to be around for all of time being the duration of your program. The first type is going to be a global variable. So that's actually what the code example has here, and I'll talk through it in a second, but just as a FYI, these are global variables. They're global because they're outside of any particular function. They're just on the outmost scope, right? They're globally available to everybody. So this is one type of variable that basically we would need to have memory available for it for the entire execution time of our program. The second type of variable is called a static variable. So static variables, the primary difference at the end of the day is really their scope. So a static variable may actually be declared inside of a function, and that static keyword, it'll actually be a keyword. I'll show you guys an example of the code on the next slide. But static is literally the keyword, and what that's doing is when you put that in front of a variable, it will mark it as this is something that should be persistent. It should be one variable that exists for the lifetime of your program. Don't do the whole, make that variable when the functions are created, or remove that variable when the function is over. It'll make it permanent. So those are two types of variables: global variables, static variables. Both of them will use static memory. Okay, so global variables. Let's just go through a little bit of an example here. So a global variable, it works like a local variable, right? I mean, you can do all the manipulations that we expect, but it has global scope. It's global to a particular file. So actually in C, right, you may have a project that's made up of many different files, and in each of those files is basically where you can declare a variable at the very top or kind of the outside scope. And that particular variable will be visible to all the functions within that particular within that particular file. It won't be available to the other files, right, or the functions in the other files, unless you use some special keywords like extern. For now, we'll just kind of visualize that we're in one file here. So in this file, I have kind of three different things going on. I have my globals over here, right, my global variables, input GB here. I have one function, and then I have my main, of course. So just to trace through that code, you'll notice here I have my two variables, right, a global and another global. Those three things are defined over here. But then if I look down, I have function one. You notice that function one actually has code that involves a global. So this code, right, is actually referring to this variable over here. So even though a global isn't a parameter, right, it could have been passed in here, or it could have maybe been declared over here. Despite that, this function still works, and the reason it works is because a global, even though it wasn't locally defined, right where this function is, it was defined in some sort of a global scope, right? It was defined as a global variable. It's way up top. It's not inside of any function. And when you do that, any function, I should say, inside that file, right, that source code file, is able to use that variable. So this code will compile fine. You won't have to worry about it. There's a little typo in this line here. I just pretend that isn't there. A_global plus plus. Again, that'll be a reference to our variable up here. So that'll be good as well. Okay. Let me fix this little typo here too. So let's say I want to maybe try simulating this program and see what happens. So at the beginning of time, you can basically think of, somewhere, right, when the program first begins to run, really even before main runs, the compiler will take care of basically identifying what are the static allocations that are necessary, and then when your program actually goes to run, the runtime environment will reserve memory for it. So these two are global variables, so as you run your program, it's actually going to allocate space for both of these two things. So it's going to allocate space for that 10, it's going to allocate space for that A. Even though you haven't really run any code yet, you'll still go and take care of that because it can see those are globals, and globals need to be around for all time, right? Anybody can use them, so I need to go ahead and create them. So this will refer to that over there. This will refer to this over here. So you can picture our program is running. Maybe you draw that picture from the previous slide deck of basically the rectangle that shows that everything's happening. So there's maybe global memory over here, heap memory over here, and let's pretend that's a well-drawn E there, and so on, right? There's a stack down here too. Beginning time, these two things are allocated. So then your program runs. Jumping out of the main, the first thing it has here is printf of the global. So the first time it does that, well, it goes and looks at that global memory. Global memory stores a 10, so a 10 will be printed out here. Now main is actually going to do a global plus plus. So that would actually change this, right? So the memory here would go to 11. That'd be fine. And then maybe you can imagine, I'll even write in here, is imagine we call func1. Doesn't take any parameters, I can just call it like this. What would happen? Well, func1 prints out the value of a underscore global. A underscore global is that global variable, and that global variable is set to 11. So 11 will print out over here. Now we can imagine, hey, what if that func1 then incremented that variable, right? So a global plus plus, well then that 11 changes to a 12. Going back down to main then prints out a global again over here. This will actually print out that 12. So the basic idea is this. There is only one variable. So whenever I print it, I'm referring to the same thing every time I print it. Whenever I do a plus plus, I'm referring to the same thing every time. So there is only one global variable here in this example, right, that we're talking about, a global. And both function and main are free to read from it, they're free to write from it. They basically just share it for the entire duration of the program. And if I had other functions, then they could all read and use that function, that global variable as well. The second thing I want to talk about is static variables. So we're still in the realm of static memory. The idea of a static variable is basically I'm now going to have a variable inside of a function, and that variable inside of a function is going to have a static modifier on it. And so it's going to act like a local variable, and it's going to be a local variable in terms of scope. So if we have a function, right, you can just picture in your head, you have a function, you create a variable inside, that variable inside of it will only be visible when that function is running. You can't get at it from anywhere else. Now, when we add that static prefix, the scope of the variable will remain the same, so the variable can only be accessed in that function, but putting that word static says, hey, instead of using a heap allocation, which is normally used for function data, use instead the static memory allocation. The effect of this is that the memory that you have allocated for that variable will be persistent over time. The memory that's used to store that global will only be released once the entire program exits, just like global variables. Maybe then the question is, what can we do with this? Why is this useful? Why would it be useful to make a variable inside of a function persistent over the execution of a program? Or, well, more specifically, over the invocation of different functions, right? We can have one function, and it can somehow, if it calls it once, and then you call it again, the second time we'll be able to see the data that the first function left in that variable. That's effectively the effect of tagging something static, because when you say static, that means you make one copy, it's permanently around for all of time, so different invocations of the function all use that same memory location. Well, here's an example of when we might use this. This is something called login. So this is just a sample function, and the idea of this function, there really should be more code here, but just for the sake of example, I've kept it simple. This function is basically meant to log users into a system and keep track of how many users have logged in. So if we look at this code, it's really short, we see over here that there is a static variable being created. Notice that static prefix, right? That static modifier. Say, okay, counter is actually going to be a static variable. So that static variable, we're obligated to set it up, right? Basically set 0 to 0, because that's going to be the value that's populated into it at the beginning of our program. So that's the special stuff there. Later on, though, in the function, we just use it like any other variable. So I have here, if verified counter plus plus, right? So if the user tries to log in and they, pass their verification for their password and username, counter goes up by 1 because the user is logged in. Now, if I imagine this, right, and let's say, the first user comes along, counter naturally is going to be 0, and then let's say the user gets in, counter plus plus, so counter becomes 1. Well, let's say user 2 comes along. User 2 comes along, logging function runs. Counter actually is going to be 1, so the value will persist. Again, that's the point of having static memory. It's something that will persist over time. So then if that user is able to be verified as well, then my counter plus plus happens again, and that value of counter will go to 2. So that counter variable is basically a persistent store. So every time I run that login function, it'll go and use the same memory for counter so it can keep track of how many users have logged into the system. If I didn't have that static keyword, well then that int counter, well that counter will just be a stack allocation. It'll be memory that's only around for the lifetime of the function. So then every time I run it, basically counter will always reset itself to 0, and it'll always go plus plus back up to 1, right, if they manage to log in correctly. And so we won't actually be able to check to count all the different users that managed to log into our system. Okay, so there we go. That is the static keyword. Again, it's making something persistent. The primary difference, in case you're wondering, between static memory and global memory is really the scope. So a global variable is defined basically at the top level scope, right? And it's something that's going to be available everywhere. Versus the function is something. Versus a static variable is something that's defined within a function itself. So scope is only in that function. That's kind of nice because all of a sudden you're defining something where you're using it. With a global variable, sometimes people have issues because the name of that global variable is basically going to be at the way top of your program, and then it's like, well, it could be very far away from the place that you actually use the thing, which can kind of make things hard to understand and hard to debug. If you're using a static variable, well, generally that declaration of that variable is only going to be valid in a specific function, so it's going to be declared right where you're using it.